Hello, welcome to NCBM 0124, Week 9 Solving Systems by Gauss Elimination. We're going to go over the steps that are written down here, and what we're going to do is solve the system first, like if it was just an equation, and we will do that by following all the instructions that are not in the shaded area. So let's get started. So first, we write the augmented matrix for the system. The augmented matrix of the system is what you see here. And we call that because we have the coefficients of the matrix, and those will be here. 1 for the x, a 3 for the y, a 2 for the x, a -1 for the y. And so those are the numbers that you could see here. On the right side, so that would be the augmented matrix. On the right side, you could see the constant terms, the 5 and the -4. And so that's what we have here and here. And so just so you know, the line that you see here in the middle of our constants and our coefficients, it's representing the equal signs that we have here on the system of equation. And after that, what we're going to do is use all the row operations that we would like, I guess. And those row operations could be interchanging rows like we have here. So two rows could be interchanged, and I don't really recommend that, but sometimes it is, you could save a lot of steps. Now you could also do any row of a matrix could be multiplied by a non-zero constant. So this constant could be a positive or a negative, and you will see that, for example, when we get here, we're going to multiply row 1 by -2. So that would be multiplying it by a constant. And another thing is, and that will actually, just to clarify, we need to multiply the whole row of a matrix. And after we do that, we could actually add the non-zero constant multiple, the row that we get from this previous step. And so we can add that to another row to create a new row. And I know this looks kind of confusing, but once we get to the examples, you guys will feel a little better about it. So let's go ahead and let's just solve our system first. And so we're going to solve the system of equations. And one thing I like to do is to number my equations. So I'm going to say this is equation 1 and this is equation 2. When you see the augmented matrix like we have here, the first row of the matrix is representing equation 1. And you can see that. And the second row of the augmented matrix is representing equation 2. And so that's what that's how we write the augmented matrix. So what we're going to do first is multiply the first equation by -2. So we will say so we're going to take the first equation, which it used to be x plus 3y equals 5, and this is a plus, sorry. We're going to multiply that whole thing by this number, -2. Okay, now when we do this, make sure that you do distribute the constant, -2, to every single term inside the parentheses. So we will have negative 2x minus 6y, and that is equal to, we also have to distribute it to the constant term. It's very important that you don't forget that step. And that will give me a negative 10. Okay, now why do we do that? Well, so that we could then add that equation to equation number 2. And so equation number 2 is this one from here. So I'm going to write it down. Two x minus y is equal to negative 4. And now we're going to do what it says there. We're going to add them. And if you notice, we are using the system of addition so that we could eliminate one of the variables. And so by doing that, negative 2x plus 2x will cancel out. That will give me a 0. Then negative 6y minus y will give me negative 7y. And that is equal, I'm trying to learn how to write with this pen. That will be equal to negative 14. So what we get from here, our next step, it says to divide both sides of the equation by negative 7. And so that's what I'm going to do, divide by negative 7. Divide by negative 7. And so what I will get from there will be positive 1 from negative 7 divided by negative 7, so positive 1y is equal to positive 2, because negative 14 divided by negative 7 is positive 2. Okay, so our next step is to to use back substitution. And so what we need to do here is to substitute the numerical value that we already have, y is equal to 2, into one of the equations. And at this point, that could be your choice. We could choose from equation 1 or equation 2. I will recommend to use equation 1, and that's just because the x has an exponent of a positive 1. That's the only reason. But you may choose to substitute it in equation number 2. That's not a problem. So actually, I need to to copy the equation. Equation number 1 says x plus 3y is equal to 5. And so if I substitute my y value with a positive 2, well, we will have this type of equation here. And so to finish solving it, of course, we have to multiply here 3 times 2. So that will give me, that will give me, positive Okay, so we have we have x plus 6 is equal to 5. And that does not look like a 5. So I'm going to try to use my pen again. Equal to 5. Yes, and so that means that x is equal to 5 minus, so it is 5 minus 6. I'm still struggling to write with this. So that will give us a x is equal to -1. And I know this looks horrible, so I need to fix it a little bit. Okay, so this is going to be, this was x is equal to 5 minus 6. And that's how we obtain that x is equal to -1. So just to confirm, we have that y is equal to 2 and x is equal to 1. So if we wanted to write the solutions here as a point, as the coordinates of a point, it would be -1, comma, and 2. So those are the solutions. Now we're gonna do the same thing that we did here, but with the augmented matrix. And so we start with the fact that we already have our augmented matrix, which is here highlighted or circled with red. And we already established that the first row is representing the first equation. So this is row 1, and this is going to be row 2. And so we do that. And what we're going to do now is follow the instructions that are in the shaded area. So for example, first we're going to multiply row 1 by -2. And so if we do that, we will have, let me write down the numbers from row 1. So that's 1, 3, having issues here writing again. So we have a 1, a 3, and a 5, and we're going to multiply those numbers by -2. And this is a parentheses, I'm sorry. So -2 times 1 is equal to -2. -2 times 3 is -6. -2 times 5 is -10. And so now what we have to do is, what it says here, add to row 2. So I'm going to write down the numbers from row 2, which are the ones here, which is +2, -1, and -4. And so if I add those numbers, I will get 0, a -7, and remember this was a 4, a -4, so this will be a -14. So now what we do with that is we replace row 2 to those new numbers. And so we create a new matrix where row 1 is still the same, such as 1, 3, and 5, and a row 2 is what we found here, 0, -7, and -14. And so that is the new augmented matrix after us applying the row operations. Now, the goal for this matrix is that at the end, we will have something that looks like this: 1, 0, 0, 1, and then the constants that we have here, the numbers, those will be the solutions for x and for y. Particularly, this one will represent the solution for x, and this one here will represent the solution for y. So let's go ahead and keep working. I have like a little less than a minute on this video, so let's just do the next step. And so the next step here, it says to multiply the second row, this new row, by -1/7. And the reason we use -1/7 is because it is the multiplicative inverse of -7, meaning that if we multiply -7 by this number that we have here, and this is only happening to row 2, so that's important to note. If we multiply -1/7 times -7, we're going to get -7/7, and that will equal to 1. So let's do this fast, and it will be a 0, 1